Alright, so I was on Jose's panel a couple of days ago, and Chris Berry tried to kick off a discussion on star trails from the ISS before he suddenly dropped.
It's the 17th time that I told you today. I'm going to share my screen. Chris Berry mentioned something, and I pulled a few pictures, and this is the first one. What are we looking at here?
All right, so that is impossible.
That's
There's no way that you would get.
This led to about 45 minutes worth of discussion, which was mainly spent trying to explain to SE Montreal how a relatively short period of rotation could be used to create a time-lapse image where there appears to be a circle of stars. As a response to that conversation, I made a little demonstration using the P1000 and a laser, and that's what this video is mainly about. But before I share that, I want to point out that at the time, no one realised that the ISS Star Trail issue came from a video by Mitchell from Australia. Mitchell's video is a classic lesson in flat earth stupidity. He couldn't be more wrong if he tried. And I was going to include some extra material to address the other points in Mitchell's video, but fortunately Where's Wally has unsurprisingly beaten me to it. So I'm going to link to his video, and if you guys haven't already seen it, make sure to go and check it out. Now, before I show the little demo, I'm just going to share a couple of clips of the convo from Jose's. This is so you could see why the demo is being done and how parts of the conversation tie in with the claims in Mitchell's video, and also to show how disingenuous SE Montreal is, given his comments later on Ranty's, which you'll hear in Wally's video.
Has to be a
This is from the ISS?
Yes. Of course it's
Isn't the ISS traveling at 17,500 miles an hour?
Well, that's why you see the light streaking on the bottom. The lights on terrestrial Earth are getting...
But how is it that it can make perfect circles?
The ISS is going around the Earth, and the Earth is rotating on its axis.
It's no different from the Earth being a couple of 100 miles bigger in diameter and somebody doing the same thing from the surface.
Right. So we're supposed to believe in 10 minutes the ISS traveling at 17.5 made that picture. Really?
It's not
because that equates to two and a half hours on Earth, 2.5 hours of spinning of Earth speed.
Yeah, which is about the length of each of those trails over 360 degrees, which is perfectly plausible. The fact that you neither understand it, can comprehend it, or have ever done photography is incidental as to whether it's true or not.
Right. Don Pettit described how he...
I am in the same boat. I cannot envision. I cannot picture this in my mind.
At the top of that page...
Jose, in La La Land, this could happen.
If you clicked on the link, he describes how we achieved these images thus. My star trail images are made by taking a time exposure of about 10 to 15 minutes. However, with modern digital cameras, 30 seconds is about the longest exposure possible due to electronic detector noise effectively snowing out the image. To achieve the longer exposures, I do what many amateur astronomers do. I take multiple 30-second exposures, then stack them using image software, thus producing the longer exposure. So that's how he did it.
Can this be modelable? Can I put some dots on a wall, some lights in the sky, and get a little device going around here, pointing a camera, go around, scalable, and get this effect?
Yes.
Damn good question.
Yes. But SE, do you not understand that lights would streak and it would streak more the faster you move? This is really basic stuff.
Yeah, no, I get that, okay. But did you hear what Jose said?
So what's the speed?
This should be able to be replicated. Dean, are you up for the challenge?
It's a piece of piss. You just have to... I know you can't think of two things at once. The motion of the stars, let's capture that. And all we need to do is point at an axis that you're actually traveling around. Here on Earth, it's the north or southern pole. Yeah, that's it. And that's how we capture that. That's brilliant. Now what we do is we'll keep pointing at those and raise ourselves up 250 miles. Does anything change? Not a thing. Brilliant. So now we've captured them. Now let's move across that surface so we can streak the stars on the ground. Does something change? Yes, we get fractionally fractionally more streaking in the radial because we're moving.
Well, I can
And
use
that's
a
it.
bicycle wheel. I can use a bicycle wheel. I can, like Chris Berry's bicycle wheel, and I can put lights on the fence and go very far away and spin that bicycle wheel with the camera pointing at it and the camera in the outside of the wheel, and then I will get this effect.
Along the way, Jose himself was a little bit unsure at first, and then he picked up on the explanation, and later on he even demonstrated this to SE using a drawing in Paint.
Your star trail is only going to be 1/10 or 36 degrees of a circle.
That's what I'm saying, George. That's exactly what I'm saying.
I got a quick point, Montreal. Before I correct me if I'm wrong, right? So this there's gonna be, it's not like from the center point, the star you're choosing for the rotation, right? You're not gonna have 3 stars above it, and those 3 stars are gonna go around this star. They're just gonna do a small trail.
Correct.
But then there's going to be other stars around it in positions. So if you take all the stars and leave just 1 star above this middle point, you're just going to see a little trail not completed as a 360 degrees around it. You know what I mean? There's many stars, and if you add them all up,
Jose,
it looks like a lot of, it just look like a lot of little.
That's what the photos show. If you look at the photos, you can see lots of arcs of stars. They're not continuous circles. They're all made up of different arcs.
Yeah, Montreal. All right, I got it. Right, this is the start we're looking at, right? And if you overpose it for whatever 11 minutes, what you're gonna see is this, maybe this, right? Just this little bit. But we don't have those 3 stars. We get a shitload of stars in between everywhere. And when you add them all up, then you're gonna see this little bit over here, another little bit over here.
I understand what they're saying.
So
but
when you add them all up at the end, it's gonna look like continuous circles, but they're not continuous circles. There's just a bunch of little trails that when you put them all together, mash up, you're gonna see like a shitload.
Yeah, and you can see
I get, but is that what we're seeing? I get the explanation, but is that actually, because it looks to me like a constant, like you can pinpoint one,
it looks like
all the way around, it seems.
No, Montreal, if you look carefully at any one of the circles, you'll see that
it would have a break.
Light arc, and then it's followed by a fainter arc and different fainted sections of arc on this.
Okay, I'll have a closer look. That explanation makes sense. I'll have a closer look.
Finally, I'm going to include a clip of Farmer's Boy explaining the period of rotation of the ISS, which comes from a separate hangout. I used this as a rough guideline on how much to move the camera during the demo, but Wally provides actual measurements in his video.
The ISS is rotating at roughly 4 degrees a minute because the underside of the ISS, as it were, the belly of the ISS is always pointed towards the Earth. And to do that, it rotates at approximately 4 degrees a minute. And as it takes approximately 90 minutes to do an orbit of the Earth, guess what 4 times 90 is? It's 360 degrees. So the same point on the ISS is always pointing towards the Earth because it's spinning itself at 4 degrees a minute.
Okay, let me show you the setup here. I've got the P1000 on this table, and I'm going to rotate it while it's recording a time lapse and move it about 45 degrees, and it's going to be a kind of star trail type time lapse. And on the P1000 that means it exposes for 25 seconds. So in the space of 25 seconds or less, I'm going to just spin this around roughly 45 degrees. Now I've already recorded, let's see if I can get this without looking at the buttons. Can't be able to see that. Let me take the torch off. A video, a standard video of that motion being made with the camera, because what we're going to be doing is looking at this laser light that I've got up on the ceiling coming from over there to mimic a star field. We're just recording standard video just now, and I'm just going to slowly turn it to roughly 45 degrees. So, P1000 on a rotating platform, move at 45 degrees within 25 seconds, which is obviously much less than 10 minutes for the ISS footage. And then That'll create a circular motion even though it's only been spun for the 45-degree portion of a circle. Now it's going to be pretty overexposed looking because there's quite a lot of light here. It's not, but it's, you know, the long exposure is not set up to record something this bright, but it will still show the effect. So let's check it out. I'll just go and do that just now. Alright, so I've just made that little quick time lapse, basically a single frame, and then I stopped it. Let me just put it on to take the torch off so you can see the screen. Give me a sec. Alright, so hopefully we'll be able to see this through the phone. Okay, that's the result. So just to show that it was a short exposure, when you hit play you can see there's no time on that movie. So if I hit play, nothing, it doesn't move because it's a single frame. If it was a proper time-lapse movie, it would last for, you know, 10 seconds or whatever it is with hundreds of frames. So I've literally stopped it after it took its first frame. Alright, this isn't going to be that easy, but I'll give it a try. The problem is that in order to see what's happening with the camera I need to have this light on, but I have to try and avoid this light bleeding and causing even more exposure for this time lapse. But we'll give it a go, so I need to hit the button. I need to hit the button here, turn the table, and then hit OK under here to stop the time lapse. So let's see how it goes. Okay, I'll just try and quickly stop that. So hopefully you might have actually heard the clicking. So it's one single 25-second exposure. Right, so let me turn the light off. And we'll try and get this to show. There we go. Don't know, let's see if I can get it to expose. Alright, so you can see that looks like a full circle. Right, so before I pack the camera away, just to kind of hammer home the point here, I'm going to use a different setting. Rather than relying on the full time-lapse setting, I've put this manually to a 5-second exposure, and I'm going to repeat the movement again and see how that turns out. Hopefully this way the overall exposure of the light won't be as strong, so we'll see how that turns out. And then I'll try and film it, which isn't the easiest. Let me just get that torch on. Alright, so this time I don't need to stop it, I'll just stop after 5 seconds, so 1, 2, 3, oh, that was pretty quick. Well, you heard that, it was only 3 seconds, and that's how much the camera moved. Out of curiosity, let's see how that turned out. And there we go, the torch off. Nice circular pattern. Again, we'll show this on the computer and it'll be much easier to see. So there you go, that was 5 seconds, and let me just put the torch back on again. This is how much the camera moved. It's butted up against here and moved to here. So I don't have the exact number, but you're probably talking roughly 20 degrees. So that's even less than is required. It's only been done in 5 seconds instead of 25, or in the case of the ISS, as I said, instead of 10 minutes. So you can see all that matters is that the camera rotates very slightly, and what it's looking at, again, let me just turn the torch off, is a full field of view that contains stars dotted all around it. And you'll get a full circle. So it was just a fairly straightforward point to be made with this video. It was just about sharing the background behind it. So thanks for watching again, guys, and be sure and check out Wally's video. Cheers.